Good day once again. This is the second video I'm making under logarithms, problems under logarithm. These are also wire questions. So we'll look at this. As I've told you earlier, if you are simplifying this, if you have anything multiplying log, you can take it as power of the log. So we can write this as log x plus 4 raised to power 6 equals to log 64. So now, what do we do here? What we should do here is since we have log of this in base 10 and also log of this one in base 10, which is general base, we can cancel the logarithm. So we'll drop this one. That's x plus 4 raised to power 6 equals to 64. Now, if we are expanding this one, it will give us a very long expression here. If you want to expand this, it will give you a very long expression because you use binomial expansion to expand this. So advisably, find a number that will take to the power of 6 that will give you 64. That should be 2. 2 raised to power 6 is the same thing as 64. Then x plus 4 raised to power 6. Now, we did this because we want to cancel the power, you understand, so that we can equate this to this, you understand, instead of expanding this one so that we'll avoid getting a long expression. Do something like this so that the power will be the same thing, then you can cancel the power and continue with your base. So here we have x plus 4 equals to 2. We collect like term. X equals to 2 minus 4. X equals to minus 2. So this is your answer to this problem. Then question number 2, we have this. So what should we do? We should rewrite this, but mind you, we have something here that's 2. We can take it as power of this, so everything will be in the same log. So we have log base 10, that's log 30 over 16 base 10 minus log 5 over 9 raised to power 2 base 10 plus log 400 all over 243 base 10. So what do we do here? What we should do here is we should factor out the logarithm. If you factor out the logarithm, then you apply law of logarithm there. Here, where you have minus, it will be division. Where you have addition, it will be multiplication. So we factor the logarithm, that's log in base 10, open bracket. This one, that's 30 over 16 divided by square of 5 is 25 over square of 9, 81. Then this is plus here, it turns to multiplication. Then 400 over 243. So here we use BODMAS because we are having we have division and multiplication. So which one should BODMAS? That's division before multiplication. So that means we need to divide this one. So if you are dividing anything with fraction, what do? You multiply with the inverse of that fraction. So you can have log in base 10 of 30 over 16 multiplied by 81 over 25. That if you are dividing with fraction, you multiply with the inverse of that fraction, which is this. So then multiply by 400 over 243. So here log where's my calculator? Okay, log 10. So here 25 can go in 400. 25 here 1, 25 in 400. 400 divided by 25, that's 16. Then 16 here 1, 16 here 1. Then what again? Okay, just leave it like this. We can now do the multiplication. That's 30 multiplied by 81 equals to 430 divided by 243, which is equals to log divided by 243. Log 10, that's log 10 base 10. And log 10 base 10 equals to 1. Log 10 base 10 equals to 1. Then question 3. This is like the question we solved from our previous, that's from our first video. I solved something like this in our first video. If you can remember, I said our aim here is to drop the power. So here we can introduce logarithm to both sides. We see log x raised to power 0.8265 equals to log 45. You don't use in base 10. Base 10. So what do we do here? This power here will multiply the logarithm. So we'll have 0.8265 log log x base 10 equals to, what's log 45? You press log 45 from your calculator. Log 45 log 45 will give you 1.6532. So what's the next thing here? Now the next thing is you divide both sides by 0.8265 divided by 0.8265. This will cancel this, so you have log x base 10 equals to this value here divided by 0.8265. That will give you 2.000, that's 2. So we reverse this one to indices. We reverse this to indices. So if you are writing this one in indices, this 10 will take this as power and you equate it to x. So therefore you have 10 raised to power 2 equals to x. So my x equals to 10 raised to power 2 is 100. 10 raised to power 2 is 100. So question number 4. Question number 4, just like question number 2, here is multiplication, it turns to, here is addition, it turns to multiplication. Here is minus, it turns to division. So we factor out the logarithm, that's log 10, open bracket, root 35 multiplied by root 2, then divided by root 7 in base 10. So here you have logarithm of root 35 times root, this will give you root 70 over root 7. Root 70, so root cancels root. Then 70 divided by 7. 70, so this one will be root 70, 70 divided by 7. So therefore you have log 70 divided by 7 will be 10. Log 10 base 10, which is equals to 1. Log 10 base 10 equals to 1.